fractions, the basics. Simplify and reduce. A fraction consists of natural numbers in the numerator, that's written above the fraction bar at the top, and the denominator, which is written below the fraction bar or the bottom. So let's look at a couple of examples of fractions, 2/7 and 3/4. Just two fractions there written just on the screen here. So the fraction bar, right, is that little line between the 2 and the 7 or between the 3 and the 4, right? And the numerator, that's the 2 and the 3, right? The 2/7, the 3/4, the 2 and the 3 are the numerator. So the denominators, there's 7 is the denominator of 2/7, and of 3/4 the denominator is 4. So that's just a little name game here of what's what there on a fraction. So we have the numerator is the top above the fraction bar, denominator bottom below the fraction bar. You will see from time to time slanted fractions. I am very much opposed to those because it is harder to know when you can and cannot use them than it is to actually use them. So I just don't ever use them. And I would suggest you don't, especially if you're trying to learn algebra. It just creates issues there when you start using slanted fractions. Because again, when you can and can't use them, that's the hard part. Not using them themselves. So I just avoid them altogether. So what is a natural number? Well, this is something you probably already know, but natural numbers we use for counting. 1, 2, 3, 4, 5. Notice 0 is not there. If you include 0, that's the whole numbers. So if you just talk about counting numbers, natural numbers, 1, 2, 3, 4, 5, 6, 7, so on and so forth. No negatives there either. An improper fraction is a fraction where the numerator is greater than the denominator. So 19/4. Right, 19 is bigger than 4. That's an improper fraction. A mixed number is the sum of a natural number and a fraction written without the addition sign. So really, this is 4 plus 3/4. In algebra, typically if two things are written beside each other, it's multiply. But in a mixed number setting, right, that comes from arithmetic. That's not multiply there. That's plus. So that's really 4 plus 3/4. Now, these two numbers actually are the same thing. The way you change them, like 4 times 4 is what? 16? 16 plus 3 is 19, so that's 19/4. Or 4 goes into 19 how many times? 4 times with what remainder? 3. That's the 3/4. So that's where that comes from. Mixed numbers and improper fractions. All right. Now, let me give you a little note about this. When you are performing operations in algebra, it is easier to work with improper fractions. So look, if you're doing a problem and it says, give me the answer as a mixed number, that's the only time I personally ever want you to do a mixed number in algebra. Don't make it a mixed number unless you have to. Now, some application problems, like if they say, how many barrels of corn do you need or barrels of wheat or something, you might say 2 2/3, okay, as opposed to 8/3. But I would accept the improper fraction unless the directions specifically say write as a mixed number. So it's better to use improper fractions in algebra, just easier to work with them. Two fractions are equivalent if they represent the same value. So writing an equivalent fraction with a smaller denominator is called reducing a fraction. A fraction is reduced to lowest terms, okay, or we call it simplified, when the numerator and denominator have no common factors other than 1, okay? So like 2 and 4 have 2 in common. That's other than 1. So that if you had something over 2, something over 4, that wouldn't be lowest terms, or 2/4, right, because they have something else in common. But if you had 2/3, then the only thing 2 and 3 have in common are 1, so you would be in lowest terms there, or simplified. So there's a fundamental principle of fractions that we need to understand in order to simplify or reduce fractions to lowest terms, okay? And that fundamental principle, if you multiply or divide both the numerator and denominator by the same non-zero number, the value of the fraction does not change. So if m over n is a fraction and p is some number that's not 0, okay, then m times p over n times p equals m over n. It's equivalent, okay? It's the same value. It may look different. 4/6 and 2/3 are the same value. 2/3 is reduced to lowest terms. 4/6 is not. So let's look at 10/15. So if we look at 10/15, can we simplify or can we reduce it to lowest terms? Well, do 10 and 15 have anything in common? And what I mean is a factor. The answer is yes, 5. So 2 times 5 is 10, and 3 times 5 is 15. So when you have this, you can divide out your common factors of 5 there. You can only do that when you multiply, not any other time. So equals 2/3, right? The 5s divide out, they actually become 1s, okay? So you get 2/3. So you can only divide out once you have factored the numerator and denominator, okay? You've expressed it in terms of multiplication and division. Here, 2 times 5 divided by 3 times 5, okay? So if it's all multiplied and divided, so all multiplied divided by all multiplied, numerator and denominator, then you can divide out common factors. If you have plus, if you had this, is that multiplied? No. So you cannot cross that out. No. You cannot do anything with this. There's plus signs. This is multiple terms, 2 terms. You can only divide out when you have one term. 2 times 5 is one term. One term because its terms are separated by pluses and minuses. Okay? So let's look here. Simplify or reduce the fraction to the lowest terms. So 10 over 14. Well, do 10 and 14 have anything in common? Yes. What do they have in common? A 2. So at least a 2. So let's change this to 5 times 2 over what? 7 times 2. So the 2's divide out. In fact, let me change colors to divide them out here. The 2's divide out, and I'm left with 5 over 7. Now, just because you divide something out doesn't mean you're done. And you don't have to show that step. If you can do it in your head and go, hey, 10 divided by 2 is 5, so let me write a 5. 14 divided by 2 is 7. 5 over 7. You can do that in your head. If you told me you did that in your head, I would believe you. Now, again, if you're in somebody else's math class, you need to ask them, can I do this in my head? Because if they want you to show your work, then you better show your work or you won't get credit. You're in their class. Okay? So 5 over 7. And then you ask yourself again, do 7 and 5 or 5 and 7 have anything else in common? And what I mean is a factor, something that divides into both of them. And the answer is no. So 5/7 is simplified or reduced to the lowest terms. So let's go over here to 33 over 45. Do 33 and 45 have anything in common? Wow, they're big numbers. Well, let's look. 33, let's see. What is 33? It's 11 times 3. Does 11 or 3 go into 45? So this is 11 times 3. And this is also, and look, divisible by 3, you can add the digits. 3 plus 3 is 6. 3 goes into 6, so it goes into 33. It doesn't tell you what it is, but it goes into it. So here, what is 4 plus 5? It's 9. Does 3 go into 9? Yes. Then 3 goes into 45. It doesn't tell you how many times, but you know it works. So 3 times, and if we go through here, it's going to be 15. 15 times 3 is 45. So I have a common factor of 3 that divides out, and I'm left with what? 11 over 15. Then I ask myself, do 11 and 15 have any common factors that can divide out? And the answer is no. So once I get to no, I know I'm simplified, reduced to lowest terms, can't go any further. So look at 35 and 50. Do 35 and 50 have anything in common? And if you go, gosh, they're big numbers, what do they end in? They end in 5 and 0. What do we know divides into everything that ends in 5 and 0? 5, right? So we know right now we can do times 5 and times 5. What times 5 is 35? That's right, 7. What about what times 5 is 50? 10. So 7 times 5 over 10 times 5. And guess what? We have a common factor of 5 that can divide out. And we end up with what? 7 over 10. 7 over 10. And then 38 over 40. Anything go into both of those? Anything divide into both 38 and 40? And you go, man, I don't know. Look, they're both what? They're both even. What do we know divides into every even number on earth? 2. So we can do something times 2 on both of these. So 40 is pretty easy. What times 2 is 40? Well, that's 20, right? And then 38, what times 2 is 38? That's a little more difficult, but look, it's 1 less 2 than 40. So it's 1 less than 20, it's 19, right? So, and if you need, however you figure that out, 19 times 2 is 38. And then what happens? My 2's divide out, and I'm left with 19 over 20. And 19 and 20 don't have anything in common, like 7 and 10 didn't on the previous one. So I can't go any further. It's simplified or it's reduced to lowest terms. All right?